When you think of Mars discoveries, whose name comes to mind? NASA, right? Maybe the European Space Agency. Maybe Elon Musk. But what if I told you that while everyone was watching the usual suspects, China quietly found something strange on Mars? No press conference, no breaking news, no social media buzz, just a quiet data release, a few images, a few radar scans, and hidden inside them, something no one expected. Not aliens, not fossils, but something that could change the way we see the red planet. A buried clue, a quiet signal, from a place called Utopia Planitia, a name that might end up far more literal than we ever imagined. And here's the part no one seems to notice. China didn't just send a rover. They sent a full science mission. It worked flawlessly, and it found this. So now, the real question isn't just what they found, it's why they're not making noise about it. What exactly did China uncover on Mars, and why does it feel like no one wants to talk about it? It wasn't gold. It wasn't a Martian pyramid or ancient alien ruins. What China found on Mars was far more subtle and far more significant. Beneath the dusty plains of Utopia Planitia, their rover, Zhurong, detected something layered, not random rock, not cracked lava, but structured deposits beneath the surface, stacked like sediment. That may not sound like much until you realize what it means. On Earth, this kind of layering almost always points to one thing: long-term water activity. Think about that. Not a flood, not ice, but standing water, staying water. Maybe an ancient Martian sea. For decades, scientists have theorized that Utopia Planitia could have been the shoreline of a massive ocean. The idea came from satellite images, vague patterns in elevation, basin-like terrain, but no one had proof. No one had ever looked underneath. Then came Zhurong. Its ground-penetrating radar scanned the soil as it rolled forward, and what it saw were horizontal layers stretching meters deep, consistent, repeated, almost deliberate, not carved by wind, not shattered by meteors. These looked like they were laid down by time, by cycles, by water. But here's the catch. This was the first time such patterns were seen at this level, from the surface, and by a Chinese-built radar. NASA has used ground-penetrating radar before, on orbiters like Charid and Marsis, but they scan from above, with lower resolution. The data is useful, but distant, interpreted. Zhurong was right there on the ground. Its radar didn't guess. It listened to the soil at close range. Every bump, every bounce in the signal meant something. And when Chinese scientists processed those signals, what emerged wasn't chaos, but order. Structured subsurface layers, like a quiet fingerprint of a world that used to be very different. Here's the twist. China didn't announce it as a breakthrough. There were no headlines like, "China confirms ocean on Mars." They quietly published the data in scientific journals. Just radar graphs, no sweeping interpretations, no hype. And maybe that's what makes it so powerful, because what the radar saw speaks for itself. If those layers are what they appear to be, we're looking at sediment built over long periods, shaped by erosion, movement, maybe even currents. It means Utopia Planitia wasn't just dry land. It may have been a basin, a seafloor, and the presence of that kind of stable water environment isn't just good news for geologists. It's exactly what astrobiologists dream of. Why? Because if there was water, and it stayed, then there was time. And where there's time, there might be life. China didn't stumble onto Mars. They didn't get lucky. What led to this discovery was years, decades, of quiet, methodical progress. Most people don't realize that China's first attempt to reach Mars failed. In 2011, a small satellite called Yinghuo-1 was launched with Russia's Phobos Grunt mission. It never left Earth orbit. The mission failed silently, falling back into the atmosphere weeks later. No big headlines, no finger pointing. And maybe that silence was the beginning of something. Because while other space agencies stream their failures and explain them in public, China does the opposite. When something breaks, they disappear, rethink, rebuild. And that's what they did. Over the next decade, China built its space program like a fortress, brick by brick. Earth observation satellites, lunar orbiters, communications networks. Then came Chang'e, the lunar program that would change everything. They didn't just land on the moon, they orbited it, soft-landed rovers, returned samples, and even touched down on the far side, something no one had done before. All of that was rehearsal for this. The Tianwen-1 mission was announced, quietly, and in 2020 launched aboard the Long March 5, China's most powerful rocket. Here's where things get serious. Instead of sending just a lander or a simple orbiter, China sent all three. An orbiter to map and relay, a lander to carry the payload, a rover to explore. One rocket, one shot. NASA didn't do that on its first try. Neither did the Soviets. China just did it, and not for show. The orbiter was packed with instruments, spectrometers, cameras, magnetometers. It scouted the Martian surface for months, analyzing light, elevation, terrain. Then, when conditions were right, the lander detached. Wrapped in a heat shield, slowed by parachutes, softened by retro rockets. On May 14, 2021, it touched down in Utopia Planitia. Not a random spot, not a lucky guess. The orbiter had mapped it, modeled it. This was a deliberate landing, and sitting inside that lander was Zhurong, a six-wheeled rover, solar-powered, fully autonomous. It didn't rush out. China waited, ran checks, monitored conditions. Only when everything was perfect did they lower the ramp and let the rover begin. And then, something fascinating happened. Nothing failed. The orbiter kept sending back data. The lander remained stable. The rover moved smoothly. For months, all three systems worked in sync. No drama, no mid-course corrections. Zhurong began scanning soil, reading weather, listening to the magnetic field, and, crucially, pulsing radar waves into the ground. Most missions just look at Mars. Zhurong listened to it. That's how they found the strange layers beneath the surface. It wasn't an accident. It wasn't even a surprise. It was by design. So what were those layers, really? And why do they matter so much? To understand that, we have to rewind, not just millions of years, but billions. Mars wasn't always a frozen desert. Its surface once had rivers, lakes, even oceans. But over time, the planet lost its atmosphere, its magnetic field, and most of its water. The red planet dried up. But did everything disappear? That's what Zhurong was sent to help answer. The layered structures it found, those horizontal bands beneath Utopia Planitia, are not random formations. They're orderly, repetitive, and spaced like sediment laid down in cycles. On Earth, you find these kinds of layers in ancient lake beds, in deltas, in shallow seas. They tell a story of slow, consistent processes, sediment being carried by water, settling, and hardening over time. The radar echoes didn't just show shapes, they showed depth. Some of the layers stretched tens of meters down, suggesting long periods of accumulation. Others ended abruptly, as if a sudden climate shift had frozen the process. It wasn't chaos, it was geology with memory. And the biggest clue? The radar didn't detect volcanic signatures. No lava flows, no chaotic scatter of rock, just clean, stratified bands, the kind that don't come from eruptions, but from erosion and deposition. That rules out one possibility. This wasn't shaped by fire, which leaves one thing, water, and not just a splash or a storm. This had the fingerprint of standing water, the kind that sticks around long enough to shape stone. Scientists have debated for years whether Mars ever had stable bodies of water. Was it just temporary floods, or actual seas that lasted thousands, maybe millions of years? Zhurong's radar gave us a clue, a real one. What it found under Utopia Planitia supports a theory long whispered about in planetary science, that this region could have been part of an ancient Martian ocean. Imagine that, a wide, shallow sea stretching across the northern hemisphere. Not deep blue waves, but muddy waters, sediment swirling, settling, building layers. Layers like the ones Zhurong saw. That alone is massive. But it gets more interesting, because water isn't just about terrain. Water is chemistry. Where there's water, there's potential for life. Especially if it sticks around, especially if it's stable, and especially if it leaves behind sedimentary records, the perfect places to trap microscopic biosignatures. That's why this discovery matters. Because if those layers are what they seem to be, then Utopia Planitia isn't just a dusty plain. It's a fossil bed, a time capsule, a place where the conditions for life might have existed and might have been recorded. This doesn't mean life was there, but it means we finally know where to look. And here's the thing, Zhurong's radar isn't done. The data it collected is still being analyzed, and buried in those waveforms, somewhere between the echoes, there may be more clues waiting to be found. Mars has always been a planet of questions. Is there life? Was there ever life? Could there be life again? And for decades, those questions have remained frustratingly unanswered. Rovers found dry riverbeds, ancient deltas, cracks that may have once held water. But it was all circumstantial, suggestive, not conclusive. Then came Zhurong. It didn't find life, but it may have found context. Those buried layers in Utopia Planitia, if they were shaped by long-term water, then they may have preserved more than just rocks. They may have trapped chemical signatures, the kind we look for in ancient Earth sediments, organic molecules, patterns in isotopes. Even microfossils, if they exist at all, are most likely to be hidden in sedimentary layers like these. And that's what makes this moment so important. Not just because of what was found, but because it tells us where to look next. For years, NASA and ESA have planned a Mars sample return mission. Delays, budget cuts, redesigns, the timeline keeps slipping. China, meanwhile, is moving fast. The Tianwen-3 mission is already in development. A bold plan to go to Mars, drill into the surface, collect samples, and bring them back to Earth. No international partnership, no borrowed tech, all made in China. And their target? Utopia Planitia. The same place Zhurong found those buried bands of sediment. If all goes as planned, China could be the first nation to return Martian soil to Earth, years ahead of NASA. And that changes everything. Because once we have those samples, the real search begins. Not with rover instruments, but in terrestrial laboratories, high-resolution spectrometers, electron microscopes, machines too large to fly, tools that can detect traces of ancient biochemistry at a level no probe ever could. We won't be guessing anymore. We'll be testing. That's the scientific impact. But there's also the silence. Zhurong's mission ended in 2022, after nearly a year of surface activity. It went silent, possibly covered in dust, possibly dormant. China didn't make a spectacle of it. No teary farewell, no emotional video montages. Just silence. And maybe that's the most fascinating part. While other nations broadcast every step, China's approach is different. They let results speak. The findings from Zhurong weren't hyped, they were published. The data wasn't teased, it was shared, in full. And now, without much fanfare, they're preparing for the next step. To return to Mars, dig deeper, and bring part of the planet home. It's not about beating NASA. It's about building something, one quiet success at a time. Zhurong might have gone silent, but the echoes of its discovery are just beginning. Zhurong's mission was never about a single rover. It wasn't about beating the West. It wasn't even about just science. It was a signal, a step, and if you look closely, the pattern becomes clear. China's space program isn't built on headlines. It's built on momentum. First, they learn to launch. Then, they learn to orbit. Then, to land. Then, to return. Step by step, each mission becomes the foundation for the next. Lunar rovers, sample returns, deep space communications. Zhurong, it was just one chapter. Now comes Tianwen-3 to bring Mars home. Then, a moon base, not for flags, but for staying. Beyond that, asteroid redirection missions, deep space nuclear propulsion crew landings on Mars by the 2030s. None of this is accidental. China is not sprinting. They're building, slowly, methodically, and with one goal in mind: to operate in deep space without needing anyone else. That's what makes this so different. For decades, space was seen as a collaboration. No one could do it alone. But China is changing that, mission by mission, tool by tool. And it started quietly, with a radar scan beneath the dust of a Martian plane. A signal that said, "We're here. We're capable. And we're just getting started." The world may not be watching, but maybe it should be.